So, next part of our lesson in lesson 8.2 is going to be on slope of a line, and we are still in the same module, which is linear relationships and slopes. And so, our learning target, I can identify the slope of a line and interpret it as the rate of change within the context of the problem. So, now we are going to learn vocabulary such as rise and run. So when I look at the slope of a line, I have written out a formula for you. It is nothing but rise over run. And rise basically means it is the vertical change between any 2 points. Okay, this is the vertical change. And the run would be the horizontal change between the same 2 points that we are using. Okay, so your what is slope again? The term slope, this is used to describe the steepness of a line. How steep is a line? Okay, it can be positive or it could be negative. All right, we'll talk about that in a minute. And slope is the rate of change between any 2 points on a line. The vertical change is the change in the y value. Okay, and this is called the rise. And the it's called the rise, while the horizontal change is the change in the x values, and that is called the run. Okay, so slope is the ratio of the rise to the run. It's a ratio written out like this. Okay, in linear relationships, the slope is always constant, and we had just done that in the previous lesson, that how the slope is always constant in linear relationships. Okay, so slope again now as we talk can be positive or negative, and I just want to show you an example on my board. So look. All right, so a slope can be positive or negative. The slope of a line that points upwards, um, from left to right, is positive, and the slope of a line that points downwards from left to right is negative. So just look at this and then look at what I just said about rise over run. And rise is the vertical change, run is the horizontal. Rise is the vertical change, run is the horizontal. Okay, so let me show you how to find slope from a graph. So let's look at this one. And over here we can see that we have the slope of a line can be found from a graph by finding the ratio of the rise to the run between any 2 points on the line. So let's look at this. And we had already said that rise is the vertical change, right? So vertical change over here between this point and this point. And so see how much we are going to be moving. And this is my vertical change. All right. And so when I'm saying slope is rise over run. Rise is my vertical change. So I can see this is 1, this is 2, and this is 3. Right? So we have gone up 3 over here, and that's what my vertical change is. And then let's look at my run, which is going to be my horizontal change between -2, -1, and 2, 2. Okay, so if I'm talking about my horizontal change, look, this is 1, 2, 3, 4. So total of 4. Okay, so therefore my rise over run is 3/4. And since this is going upward like this, is going positively, this is going to be a positive slope. Okay, and when reading the rise and run from a graph, a rise up is positive and a rise down is negative. A run to the right is positive and a run to the left is negative. Okay, so let's do an example, and we are going to look at this graph. Pull this down a little bit. Okay, so let's look at this graph over here. And so the graph shows the cost of muffins at a bake sale. Find the slope of the line. So here is my graph over here. And to calculate the slope, you're going to find the ratio of the vertical change, which is the rise. Again, slope is equal to what? It's equal to rise over run. The vertical change over the horizontal change. So rise over run. Okay. Now, so let's look at this one. And in this case, the points are, we're going to take 2, 4, and 3, 6. And when I'm looking at the vertical change, what do I see? I have 1 and I have 2. Okay, so my rise is 2. My run is just 1. So this is 2 over 1. Okay, and so therefore the slope of the line is 2 over 1, which is over 2. So that is the slope of the line in this case, just by looking at the graph. So let's look at another graph, just to make sure that you've understood this one. Okay, so we are now going to look again, rise over run. Okay, so slope. Okay, slope is rise over run. Okay, and we are looking at this and this comparison. So let's see how much. Rise means the vertical change that we are seeing. And so here 1 and 2. Okay, so that is my rise, and my run is the horizontal 1, 2, and this is 3. So this is 3. Okay, so it is 2 over 3 or 6/10 repeating, because 2/3 is nothing but 6/10 repeating. Okay, now let's find the slope from a graph, which might be a negative slope also. Okay, so let's look at this one. Pull this down a little bit. And okay. So let's look at this problem. The graph shows the amount of water in a leaking bucket over time. Okay, let me just push this back. So here we go. All right. So the graph shows the amount of water in a leaking bucket over time. Find the slope of the line. Okay. So to calculate the slope, we are going to find the ratio of the vertical change to the horizontal change between any 2 points on the line. And in this case, the points are 3, 5, and 9, 1. Okay. So again, what is slope? Slope is your rise over run. Okay. So slope is rise over run. And so we are looking at first the vertical part. Okay, and so when I'm looking at this is going downward. So 1, 2, 3, 4. So that's a -4 since it's going down. Okay, and then we look at the run over here, which is 1, 2, 3, 4, 5, 6. So this is -4 and this is 6. So my run is 6. Okay, and then I just simplify this ratio and I get -2 over 3. And this is what my slope of the line is, -2/3. Okay, you can also write it like this, -2/3. This can be written like this. All right, let's do another example of a negative slope. So let's look at this one. and we are trying to find the slope of the line. Okay, so my points are here and here. Okay, so once again, your slope, which is also m, okay, but right now I'm just writing it like this, is equal to rise over run. Rise is the vertical. 1, 2, 3, 4. This is -4, right? Since it's going down. And this is how much? This is going right. So this is going down 4 and 1 right. So therefore, -4 over 1, that is my slope, or what is that going to be? -4. So this is the slope of the line. All right. So let's learn slopes from a table. Let me show this to you. So you can determine the slope from a table by finding the ratio of the vertical change y to the horizontal change x. All right. And so let's look at this table over here in a minute. The table shows a linear relationship between the balance in a bank account and the number of transactions. The relationship is linear because there's a constant rate of change or slope, and the slope of the relationship shown is -$10 per transaction. So look, just want you to see this first. So as you can see over here, the number of transactions, it keeps increasing by 3 over here, and that keeps going down by 30. So if I do 30 divided by 3, what do I, -30 divided by 3, what do I get? I get -10 per transaction. Okay, and so what is my slope going to be? Okay, my slope is, again, change in y over change in x, or you have, yes, so what is that? Change in y over change in x, right? So what's my change in y over here? My change in y is this, because this is my y, -30 over, what is my change in x, is going to be 3. Okay, and so therefore this gives me -10 over 1, and this is my slope, -10 over 1. Okay, so let's find the slope from a table. Let's look at this one. The points given in the table lie on a line. Find the slope of the line and check your solution. Okay, so when I'm looking at this again, what is slope? You're going to choose any 2 points from the table to find the changes in the x and the y values. So let's go ahead, and we are going to use the x and y as this one and this one. Okay, we are going to use 2 points from the table to find the changes in the x and y values. So what are my points over here? X is -6 and y is -2 in this one. In the second one, I have x is -2 and y is -1. Okay, so once again, we are going to use these points, and we are going to see the changes in the x and the y values. So remember, this is x1 and this is y1, and this is x2 and this is y2. Okay, so what is slope again? Slope is the change in y. So y2 minus y1, basically. So once again, I'm going to write it out. Slope is change in y over change in x. Okay, let me use the black color. There we go. You can see that better. Okay, so change in y over change in x. So let's look at what is y2. So we have -1 or -1 minus, what is y1? It is -2. So minus -2 over the change in x is going to be -2 minus negative 6. Okay, so what do I get? Negative 1 minus negative 2, that becomes negative 1 plus 2, right? Because you're adding the opposite, and that gives me 1 over negative 2, and that becomes plus 6 over 4. So this becomes the slope of the line, which is 1/4. And to check, you can choose two different points from the table and find the slope. Okay, you can use another one. Let's say I use 6, 1, and I use this one. Okay, I use these two. So what is this? This is 0 minus 1 because change in y. Okay, for 6, 1 and 2, 0. I'm going to have 0 minus 1. If I'm for checking, this is to check my work. Check the slope. Okay, so change in y, okay, over change in x, which is 2 minus 6. And what is 0 minus 1 is going to be negative 1 over 2 minus 6 is negative 4. And so negative by negative gives me positive, and I get 1/4 when I'm simplifying. So see, I get exactly the same thing. All right, so this is the best way to check, because you're just going to choose two different points from the table and find the slope. Okay, and so now basically, again, let's use the point slope formula, and it's basically the same thing, is nothing but the change in y and over the change in x. So let me just show that to you, and that's exactly what I was doing in a little bit. Okay, so you can find the slope of a line from any 2 points on the line using the slope formula. Okay, so you have the first ordered pair, you have the second ordered pair, and then all I'm doing is you're doing y2 minus y1 over x2 minus x1. That is equal to slope, which is represented by the variable m. M is equal to y2 minus y1 over x2 minus x1. Okay, now so let's look at this one. You can find the slope of the line from any 2 points on the line. Okay, and using the slope formula, it does not matter which points you define as x1 y1 and x2 y2. Okay, however, the coordinates of both points must be used in the same order. Okay, now so here are the words, and you have the model given to you, and then there is your formula. Okay, so the slope of a line passing through points x1, y1, x2, y2 is the ratio of the difference in the y coordinates to the difference in the x coordinates. So again, as I said earlier, m it represents the slope, and m is equal to y2 minus y1 over x2 minus x1. Okay, and x2 is not equal to x1. And so here is what I want to show you. Okay, all right, so let's go ahead and solve this one to find the slope of the line using the points 1, 3, and 5, 6. Okay, using the points 1, 3, and 5, 6. So we know that what is my slope? Slope is rise over run. Okay, so m, which is slope, remember, m is slope, is equal to rise over run. And so what is m? It is the change in y over change in x. Over change in x. Okay, so if I'm looking at this, what is the change in y? So slope is y2 minus y1 over x2 minus x1. And then when I look at this, what I have over here, there are several things that I can look at. I can look at the rise, and I can look at the run. Okay, Or so that is just going to straight up show me that my rise over here is 1, 2, 3. So this is 3. This is 1, 2, 3, 4 is my run. So 3 over 4 is going to be my slope, or I can look at y2 minus y1. So this is x1, this is y1. This is x2, and this is y2. Okay, so if I'm looking at this up close, okay, so what is y2 minus y1? It's going to be 6 minus 3. Okay, x2 minus x1 is going to be 5 minus 1. What is 6 minus 3? I get 3. 5 minus 1 is 4. So here is my slope. The slope of the line is 3/4. Okay, so either I can do the change in y over change in x, or the rise and run. You still is exactly the same thing. All right, now let's do another problem. Let's look at this. Find the slope of the line that passes through R. Your ordered pair is 1, 2, and S, where the ordered pair is -4 and 3. And then we check a solution. So let's look at this one. Okay, so let's talk about slope is slope is change in y over change in x. All right, so and that is the slope formula. So let's look at the change in y. Okay, so we have x1 y1 is going to be 1, 2, and x2 y2 is going to be -4, -3. Okay, so this is going to be, again, what did I say? This is x1 y1. Okay, and so and then I have x2 and y2. Okay, so x1 y1 is 1, 2, x2 y2 is going to be -4, 3. And so when I am looking at what is my change in y, it's going to be here. This is my x2 and y2. Okay, so y2 minus y1, that means 3 minus 2. 3 minus 2. All right, and then I have x2 minus x1, so -4 minus 1. -4 minus 1. -4 minus this one. So what am I left with? What is 3 minus 2? I get 1, and -4 and another -1, that gives me -5. All right, so this is nothing but -1/5 is my slope. Okay. Now, the next thing I want to talk to you about are zero and undefined slopes with horizontal and vertical lines. So let me show you an example what that looks like. So let's look at this one. A horizontal line is a straight line. Do we see any slant? No. So that is why horizontal lines have a slope of 0, as you can see over here. Okay, and the vertical lines have an undefined slope. So look, vertical lines have an undefined slope. All right, so let's go ahead and solve some problems with these. And so let's look at this one. So let's go ahead and find the slope of a line that passes through point A, which the ordered pair is -3, 4, and B, where the ordered pair is 2 and 4. Okay, so I can see this is to the right, this is to the left. So this is going to be my x1, y1, and this is going to, because it's on the left, that's going to be x2, y2. Okay, so this is my x1, y1 ordered pair. This is my x2, y2 ordered pair. And now I'm going to find what is the slope formula. M is equal to y2 minus y1, change in y over change in x, which is x2 minus x1. Okay, and so as I said, this is to the right, so this is your x1 y1, that is to the left, that is going to be x2 y2 in that case. Okay, so we have what is y2. Y2 is going to be 4 minus 4. Okay, because this is 4 and that's 4, over what is x2. X2 is negative 3, and what is x1 is going to be 2. This is your x here. This is x1, that's x2. So x2 minus x1. Okay, and so what do I get? What is 4 minus 4? Is going to be 0. What is negative 3 minus 2? I get negative 5. If I simplify, what is this? 0. Okay, and so the slope of the line is 0. So when you're looking that your y's are the same, okay, so that just 4 minus 4, that is going to give you a horizontal line, and that tells me that the slope is going to be 0. Okay, why is the slope 0 in this case? As you can see, there is absolutely no change in the y values, and I just said 4 minus 4, so there's no change. Okay, so the numerator of the slope ratio will be 0. The x values will change. So the denominator will be a non-zero number. And 0 divided by any non-zero number is going to give me 0. Okay, now let's look at talking about how can you determine that the slope is 0 without using the slope formula. See, the line is a horizontal line which has no rise. Okay, there's no rise. It's a horizontal line. So therefore the slope must be obviously 0. All right. Now, let's talk about line with an undefined slope, and undefined basically where my line is going to be, where my line is going to be vertical. So if I look at this one, all right, and you have to find the slope that is passing through this. Okay, so I have t is 1 3 and u is going to be your 1 0. All right, so now when I look at this one and I have got to calculate, so x1 y1 is going to be 1 3. This is my This is x1, y1, and this is x2, y2. Okay, so again, what is slope? y2 minus y1 over x2 minus x1. Okay, now, so what is the first one? Let's look at this. What is y2 minus y1? Is 0 minus 3, right? 0 minus 3 over x2 is 1 minus 1, 1 minus 1, all right, which is negative 3 over 0. And no, that's not happening. Okay, the slope is undefined. So this line is going to be undefined. Undefined. Okay. Why is the slope undefined? And it's undefined because there's no change in the x values. So the denominator of the slope ratio will be 0. Division by 0 is undefined, and that's why we get the answer as undefined. How could you determine that the slope is undefined without using the slope formula? Because if I'm looking at it, is it a vertical line? Yes, it is. So the slope of any vertical line is going to be undefined. Okay. So that's what this lesson 8.2 under the module linear relationships and slope is about, is how to find the slope. You can identify the slope. You can use your slope formula, and you also know that rise over run, the difference in y over difference in x is going to give you the slope of a line. Okay. All right. Have a great day, everyone.